Hi everyone, welcome to today's topic. Today we are going to talk about descriptive statistics and more on spread and dispersion aspect. Yeah, so let's get started. So in the last video, we talked about what is descriptive statistics and we concentrated on central tendency aspect. So just a quick recap, descriptive statistics is all about summarizing and describing your data. And there are various ways to do this. Yeah, today our point of discussion is more on spread and variability. We do it by measures like range, IQR, which stands for interquartile range, variance, and standard deviation. So let's get started. So let's see first what is measure of this dispersion. So measure of dispersion, which is also referred as measure of spread, is used to describe the variability in your data. So normally we use this in conjunction with central tendency. So rather than just relying on central tendency measures like mean, median, mode, what if we could accompany that with measure of dispersion, which says how your data is spread with respect to the central tendency measure. So if example that we are considering mean, how your data is spread around your mean. So a variable spread is a degree to which the scores on the variable differ from each other. So I'm going to take an example which would help you to understand these concepts more better. So let's take example like you have three players and each of the three players have the same average score. Okay, and then if there is a like if there is a coach that who would want to select either one of the player, then how would he would want to pick it? So he can't rely on any of the measure of central tendency like mean, median, mode because they're all same. So what should he use, or what technique he should use to select one player? So that's the agenda. Yeah. So if you see, I've written down the scores of each player. And if you see, this is the data of some test matches. And for all the three players, the mean, median, and mode, they are all 10. Yeah. Now, if I want to select one player out of these, how would I do it? So normally the key area is I would look for a player who is more consistent, or if I want to talk in terms of variability terms, the variability is less. There is less variance in the data, right? So he's more consistent. He is performing less variable. That would be the player I want. Yeah. So let's talk about the first measure, which is the range. This is very simple, right? What you do is you pick up the highest value and the lowest value. So for example, player one, the lowest value is 7 and the highest value is 13. And then you just subtract them. So the formula is range equal to highest value minus lowest value. For player one, it would be 13 minus 7, which would be 6. For player two, it would be 7 and player three would be 27. Yeah. Now, if you see player one and player two, they're pretty close. Player three is like the difference is huge. Okay, and why? Because if you see, there's an outlier, right? Or maybe this 30 is very different from majority of the scores that are scored by player three, right? So in case when you have certain outliers, range might not give you a correct picture. So there could be other ways to do it. Yeah. So one other way would be finding the interquartile range. Okay, so before I talk about interquartile range, let me just give you a brief idea what are quartiles. If you already know, that is good, but let's try to see what is interquartile range. So if you see, I've arranged this data in a uh, ascending order. So this data is sorted. If I talk about median, which we saw in the last video, median would be the center value. There are two center values over here, 53 and 55. So I'll take an average, which would be 54. This would be the median. Okay, now median would also be called as Q2, or the 50% of your data. That means, can I say that 50% of my data lies below 54 and 50% of my data is above 54, right? So 54 would be the Q2 or 50th percentile or the median. Now, if I want to look at my lower half, okay, so let's take if I just divide this data into two equal parts, the lower half and the upper half, I could, very well calculate what is the lower half. So in this case, if I have to calculate the median, it would be 52, okay, which we will call it as Q1 because this is the median of the lower half, okay, and we give it a percentile as 25 percentile, meaning 25% of my data is below 52 and 75% of my data is above 52. And similarly, you do the upper half. So quartiles, okay, divide your data into 4 equal parts. Data into 4 equal parts. Okay, now if I ask you that, if I have a line and I need to maybe, make 4 equal parts. Okay, how many lines would you need? Okay, so you'll need 3 lines, right? So if you have a line and I need to divide it into 4 equal parts, you'll need three lines, three separations, right? So this would be called as Q1, Q2, Q3, and this is 25%, 50%, and 75%. Yeah. So with this space, let's go to the previous slide, which talks about interquartile range. Sorry. Yeah. So interquartile range is the measure where middle 50% of your data. So in range, we did highest value minus lowest value. For interquartile range, we will do Q3 minus Q1. That means the upper quartile minus lower quartile. So if we go with this understanding, for player 1, we'll do the calculation. We'll find Q1, Q3 and Q1, and this is what we'll get. Okay, so for player 1, we got an interquartile range as 3. For player 2, it is 1, and player 3, it is 5. Yeah, so this at least is better than finding the range because see, here you get 5. Yeah, so you are eliminating the effect of outliers. So still not, very decisive point where we want to select each one player, right? So at least there should be a tie between player 1 and 2, right? Because the difference is on a lower side. Yeah, so let's see other ways of how we can decide whether it's a player 1 or a player 2. So we talked about range, interquartile range, and let's talk about the third measure, which is variance. Now, there is a limitation on range and interquartile range, right? What if you look at the formula, they are only dependent on 2 values, which is highest minus lowest, or it would be Q3 minus Q1. They don't take into account each of the data point. So that's a bit of a limitation. But okay, when you talk about variance, it takes into consideration all the data points. So what's the definition of variance? Variance measures variability from an average or a mean. So how each of the data point differs with respect to mean. So it measures how each number is differ from its mean, right? And this is the formula. So you take each of the point, which is your x, you subtract the mean from each of the point, you square it and then divide by number of data points. So that would be your variance, which is also denoted by sigma square. So for example, if I want to do for player 1, we know that mean is 10, right? So for each of the value, you'll say 7 minus 10, okay, and then you'll square it. Even if it is negative, it won't matter because you're squaring it. So 7 minus 10, which would be 3 square, plus 8 minus 10, which would be 2 square, again 8 minus 10, which would be 2 square, and so on and so forth. So if you see in this formula, we are adding all these values, right? So we are taking into account each and every value in the series, right? So for player 1, we get it as 3. Player 2, we get it as 3.36, and player we get it as a higher value because of the known reason, which is 30, right? So player 1, 3, player 2, 3.36, and then player 3. So there was a gap or tie between player 1 and player 2. We were not able to decide, but in this case, If I were a coach, I would go with player 3. Why? Because the whole idea was that the variability should be less. The player should be more consistent. So if I look at the variance calculation, of course, there's a very little difference. But if I have to choose between player 1 and player 2, we would certainly choose player 1. Okay, where the variability is 3. Yeah. The last one, it's not, much difference what you're doing because we are squaring it over here. Okay, so if there are certain units, so in this case, there are no units, but in case there are units like centimeter, meter, you're ideally squaring it, right? So you'll get centimeter square, meter square. But okay, if you want to get back to the original unit, you will take a root. So standard deviation is nothing but a root of variance, which is denoted by sigma. And then if you just take a root of all the variance, you get the value as player 1 as 1.73, player 2 as 1.83, and player 3 as 7.02. In this also, because it's just the root, the standard deviation would also be less for player 1. So we conclude that at least if you want to go for measure of variability and spread, you should concentrate on variance and standard deviation. Yeah. So let's take a quick summary or a recap of the measure of variability and spread. So we studied range, which is just highest value minus lowest value. We looked at interquartile range, which is upper quartile minus lower quartile, which is Q3 minus Q1. And then finally, standard deviation and variance, where you take into consideration each of the point, subtract mean from each of the point, and do the calculation. Yeah, so in short, variability gives you how your data is spread across your or around your central tendency and could be very important to make a decision in addition to central tendency aspect. Thank you for your time. I hope you enjoyed this video. Let me know in your comment section. Thanks a lot.